Since the gas crisis of the 70s, increasing numbers of heavy vehicles with high-pressure radials have been bearing down on America's highways. These high-pressure radials were found to significantly reduce fuel costs and were rapidly implemented after introduction. This resulted in increased rutting, fatigue cracking, and loss of cohesion due to moisture damage. When super singles are adopted by the trucking industry, additional pressure will be brought to bear on the nation's highways, causing increased rutting and challenges to pavement designers. This cross-section was cut from an interstate truck lane, soon after placement, showing rutting extending down into the intermediate pavement layer. This is an example of what can happen even with good design procedures, good field quality control, and good production and placement techniques. PTI's analyzer would have identified this problem before it left the design and testing laboratory. As a matter of fact, even when using state-of-the-art asphalt plants to blend and mix all the ingredients necessary, and in the right proportions to achieve consistent high-quality hot mix asphalt, even with state-of-the-art pavers and material transfer vehicles which produce a non-segregated, uniformly compacted, smoothly constructed pavement, if the performance is not built into the mixture, then certain premature distress will occur. Pavement Technology's Analyzer can ensure that the owner's investment is protected by eliminating marginal or poor performing mixtures. We know the chain of events leading up to successful placement of high-performance mixes, beginning with lab design and ending with long, satisfactory pavement life. We know the problems which come from having a weak link in the chain, but the greatest problems come from having a missing link. And the missing link in quality asphalt pavement can be provided by PTI's proof testing equipment, which can be used both in the mixture design phase and also as a quality control indicator. PTI's Asphalt Pavement Analyzer, the best choice for mixture proof testing equipment and the missing link in quality asphalt pavement. The Asphalt Pavement Analyzer and its companion, the Asphalt Vibratory Compactor, which prepares specimens for testing, are the best laboratory equipment for testing design mixtures prior to placement. Pavement Technology's Analyzer tests for rutting, fatigue cracking, and loss of cohesion due to moisture damage. The Asphalt Pavement Analyzer is a universal proof tester and works well not only for volumetric mix designs, but also for any mix design process, including future ones. PTI's Analyzer allows the design engineer to achieve a balance between mixed properties. An example is when rut resistance characteristics are balanced against resistance to fatigue cracking. Testing steps are simple and direct. Test specimens may be prepared by a gyratory compactor or in Pavement Technology's vibratory compactor or by other methods used by the mix designer. Rectangular molds or cylindrical molds are filled with hot asphalt mix and placed under the compaction head. The compactor head is sprayed with a light coat of non-petroleum, non-stick agent such as PAM and is lowered onto the mold. The vibratory compactor kneads the mixture by alternating vibrations on first one side and then the other. The AVC compacts the mixture by a vibration, which simulates a vibratory roller. It takes less than a minute to compact the mixture to the desired density, because the vibratory action really brings the aggregate particles to life, positioning them rapidly just as a vibratory roller does. The procedure is not only quick, but provides a consistent density throughout the test specimen. Users prefer it to other compactors when producing large numbers of test specimens because of the time it saves and ease of use. The completed specimen is moved over the extractor, and a pneumatic cylinder presses the specimen easily out of its mold. The asphalt specimen can then be heated or cooled to its testing temperature in the built-in conditioning chamber. Specimens are then secured to the testing tray. The hose assembly lowers into position, and concave wheels run over rubber hoses for 8,000 cycles to simulate traffic loads. While the APA has the capability to allow the designer to set the test parameters to meet the environmental and loading conditions for the project being designed, typical test conditions are temperature 40 degrees Celsius, 105 degrees Fahrenheit, 49 degrees Celsius, 120 degrees Fahrenheit for high-performance mixes. Load, 45 kilograms, 100 pounds. Pressure, 689 kilopascals, 100 psi. Contact pressure, 689 kilopascals, 100 psi. The APA provides the designer with the flexibility to test 3 different designs simultaneously, or one design under 3 different loading conditions. This gives the designer the ability to rank performance using variable test criteria. Testing procedures stop automatically at preset cycles. Counters show cycles remaining. The insulated environmental chamber can be heated to 60 degrees Celsius, 140 degrees Fahrenheit, or cooled to 4 degrees Celsius, 40 degrees Fahrenheit, by onboard refrigeration and heating equipment. Water temperatures are kept constant by an electric heater in the water tank. Individual wheel controls provide for calibration or running positions. Each wheel has its own cycle counter. On this display, 2 wheels have stopped and only one remains running in a fatigue cracking test. A stainless steel tank, pump, and reservoir are provided to test specimens underwater for moisture susceptibility. The tank raises into position, fills with water, and the entire cycle is run underwater. Water is then drained and the tank is lowered. Each step is easily handled from the control panel. Periodically, each wheel should be calibrated. This too is a short procedure, easily done with a load cell provided with the analyzer. The blue pressure sensor is placed under one wheel at a time, and the regulator control on the control panel is adjusted until the desired pressure is obtained. The typical pressure is 689 kilopascals or 100 psi, plus or minus 1%. As mixtures are graded coarser for heavier traffic roads, it is expected that fatigue cracking will become of more concern to the designer. And as coarse-graded mixtures are utilized to resist rutting, there will be an increased tendency for fatigue cracking to occur, especially if adequate roadway compaction is not achieved. Pavement Technology's Analyzer tests for fatigue cracking using a metal wheel directly applied to the test specimen. A metal wheel is used since fatigue testing requires somewhat longer testing times. Only rectangular beams can be used for this test, since cylindrical specimens would not be suitable for fatigue loading. An embedded wire circuit at the bottom of each beam sample carries a direct current which allows the wheel to operate. When fatigue cracking occurs, the wire breaks and the wheel stops. The cycle counter records when the break occurred on each individual wheel. In this specimen, the fatigue crack is shown, indicated between the white lines drawn on the test specimen to mark its position. Common tools are used to separate the mold after testing. These molds are made of high-density polyethylene, chosen because it has the approximate moduli of asphalt concrete. Supports are provided at each end of the beam along with channels for the wiring circuit. Foam pads support the entire beam to prevent creep that may possibly occur due to dead weight of the beam specimen. Due to the low cost of the equipment, its ease of use, and reliable and consistent results, many states, universities, and material suppliers, as well as hot mix asphalt producers, have already purchased and are using Pavement Technology's Analyzer and Vibratory Compactor. As more and more contracts are let, the number continues to climb because of the proof testing benefit and the immediate results which can be used to determine the strength of an asphalt mix design. Proof testing guards against the high cost of removing a mixture due to a poor or marginal mix design, and PTI's Analyzer can test the mix design before the rubber meets the road.